Good morning, students. I'm R. Shagila Devi, Assistant Professor in Department of Computer Science Engineering in Rohini College of Engineering and Technology. So, welcome to the Unit 4 of Deep Learning course. Today, we are going to discuss about the performance matrices. It is an essential topic used to evaluate the machine learning model. So first we are going to discuss about the introduction to the performance matrices. In machine learning, building a model is only the first step. We must evaluate how well the model performs on unseen data. And for this we use a matrices, that is performance matrices. So this matrices helps us in understanding the model quality, compare the different models and tune the hyperparameters and check whether the model generalizes well. So that there are different tasks used in different matrices. So the classification uses one set and the regression uses another set. So our goal is a simple thing is to measure how well the model performs on new or unseen data. Next is performance matrices for classification. So classification is a task where the input data is assigned to a predefined categories. For example, email, spam detection, or the disease prediction or sentiment analysis. Some commonly used performance matrices for classification are accuracy, confusion matrix, precision, recall, F1 score, and AUC ROC curve. First one is accuracy. Accuracy is the simplest and the most widely used metric. It is calculated as accuracy is equal to correct prediction divided by total prediction. Accuracy works well when all the classes have similar proportions. But if the data set is highly imbalanced, for example 95% of negative data and 5% of positive data, the accuracy alone cannot find out the correct cannot be a correct matrix, so it creates a misleading. So we use more detailed matrices when the classes is imbalance. Next is confusion matrix. The confusion matrix gives a complete picture of classification performance. It compares the predicted value with the actual value. It consists of true positive, that is correctly predicted positives, true negative, that is correctly predicted negatives, false positive, negatively predicted positives, false negatives, positively predicted negatives. So this matrix is a foundation for calculating precision, recall, and F1 score. Next is precision and recall. Precision and recall are the two important matrices especially used when dealing with the imbalanced data set. So precision is equal to true positive divided by true positive plus false positive. So precision tells us out of all predicted positives how many were actually positive. So it is used when the false alarms are costly, for example in email spam classification. And recall is equal to true positive divided by true positive plus false positive. So recall tells us that out of all the actual positives how many were detected correctly. So both precision and recall focuses on different types of errors. Next is F1 score. The F1 score is the harmonic mean of precision and recall. F1 score is equal to 2 into precision into recall divided by precision plus recall. It gives a balanced evaluation when both false positives and false negatives are important. It is especially useful when the classes are imbalanced. And next is AUC ROC curve. The ROC curve plots it plots against the true positive rate and the false positive rate. So AUC or the area under curves summarizes the ROC curves into single number. So if AUC is equal to 1, it's a perfect model. If AUC is equal to 0.5, the model is not better than the better for random guessing. So the ROC AUC is used to understand how well the model separates positive and negative classes across different thresholds. Next is performance matrices for regression. For regression problem, the target variable is continuous, like predicting the house price or the temperature values. Some commonly used regression performance matrices are mean absolute error, mean square error, and R square score, and adjusted R square. So these matrices measure how far the predictions are from actual values. And next is MAE and MSE. Mean absolute error. It's an average of absolute difference between the actual and the predicted value. It treats all the errors equally. Then mean square error, MSE, which takes the square of the error before averaging. So because errors are squared, MSE penalize large errors more than MAE. This makes the MSE more sensitive to the outlier. And R2 and adjust in R2, then R2 score the coefficient determination tells us how much the variance in the target variable is explained by the model. So the value ranges from 0 to 1. A value closer to 1 indicates the better performance. However, the R square always increases when you add more features. So when we adjust R square value, which penalizes the unnecessary features and gives a more realistic measures, especially in multiple regression. So adjusting R square is more reliable when comparing models with different number of predictions. So this is about in this today's session we have discussed about the performance matrices, which helps in evaluating the model accuracy and stability. Okay, thank you.